Hi class, we are now on chapter 2, 10.2a. In solids and liquids, forces of attraction hold particles together. These forces vary for different types of substances. In this section, we will explore the different ways that particles can be arranged within solids and liquids and learn about the properties that result from the unique structures. We first talked about ionic compounds in chapter 5. In these compounds, positive and negative ions pack tightly together in rigid frameworks called lattices. Because the interactions between the ions are so strong, it takes a tremendous amount of energy to disrupt the lattices. As a result, most ionic compounds have very high melting points. These substances also tend to be very hard and very brittle. Elemental metals, as well as mixtures of metals, are called alloys. Usually form ordered lattices of tightly packed atoms. Metallic atoms have a loose hold on their outer electrons, and the electrons move easily from one atom to the next. Because of this property, metals are good conductors of electricity. While atoms pack tightly together in metallic solids, the neutral metal atoms do not bind as tightly to each other as the oppositely charged ions in an ionic compound. Because of this, metal lattice is not as rigid or as ionic as lattice, not lettuce. And the shapes of the metallic solids are easily altered. Metals are malleable, meaning they can be pounded into different shapes. And they are ductile, meaning they can be stretched into wire. So malleable, think of that you can hammer them or pound them into flat sheets. And ductile, they can be put into wires. Metals have moderately high melting points. Metals like iron, aluminum, and copper are commonly melted and molded into useful shapes. Molecular substance. Many substances are made of molecules. Recall that molecules are discrete units of atoms held together by covalent bonds. I want to make sure I'm covering this right. Recall that molecules are discrete units of atoms held together by covalent bonds. Remember, covalent bonds, they share electrons within each other to fill an octet or a duet. Covalent bonds, the forces of attraction within a molecule are very strong, but the forces between the individual molecules, called intermolecular forces, are much weaker. As a result, molecular compounds usually have lower melting and boiling points than ionic compounds. We will explore intermolecular forces in more detail in the next lesson. The exact properties of molecular substances vary widely depending on the strength of the forces that hold them together. So if we look here, we can see there are forces going on within the molecules, and then there are forces that are going on between molecules. So now we're at covalent networks and polymers. Some compounds contain covalent bonds, but differ significantly from molecular solids but differ significantly from the molecular solids described previously. For example, elemental carbon exists in two primary forms, diamond and graphite. Both of these examples of covalent networks, lattices of connected covalent bonds that form giant molecules. In a diamond, each carbon atom has 4 single bonds and a tetrahedral geometry. The single bonds repeat indefinitely in 3 dimensions, resulting in a rigid structure that is among the hardest and most durable substances known. In graphite, the carbon atoms each have a trigonal planar geometry. The atoms are arranged in 2-dimensional sheets that slide easily over each other. As a result, graphite is softer and is used as the writing material in most pencils. Polymers are compounds that contain long chains of covalently bonded atoms. There are many natural occurring polymers, including cellulose, the structural component of wood, proteins, and starch, a major component of many staple foods, such as rice and potatoes. Plastics such as polyethylene and polyvinyl chloride, PVC, are synthetic polymers. The long chains of polymers are made of small repeating units joined together by covalent bonds. So let's briefly summarize these ideas. Ionic substances are often hard, brittle substances with high melting points. Metallic substances conduct electricity, and may be pounded or stretched into different shapes. Molecular substances are composed of discrete molecules. The melting and boiling points of these substances depend on the forces of attraction between the molecules. And finally, covalent networks in polymers have long sequences of covalent bonds resulting in huge molecules. Okay, let's go to some problems. There are some slides prior to this that it looks like, for some reason on my screen, they come out and I can see them clearly, but when I do them in a slideshow like this, the questions aren't coming out. So I'll fix this when I put the, I put my PowerPoints online. I will fix this so you guys can see the questions, even though you're, for some whatever reason, I can't go through them because I can't see what the questions are. So unfortunately, I've got to skip over a few of them right now. Solid carbon dioxide is also called dry ice. It is a covalent solid. Remember, covalent, these are non-metals. That's covalent bonds. It's carbon dioxide. And yes, dry ice, that's what CO2 is. So when you see it sublimating, it is releasing the CO2 as a gas. Potassium permanganate is so let's take a look at what that is. Let's break it down. It's an ionic compound. You're dealing with we have the potassium, and then we have manganate, and then we have O4, but you see this is a polyatomic ion right here.